Hi friends, in this video I'm going to show you how to recover U-boot on ConnectCore ATM Nano device using microSD card. If the bootloader has been erased from the storage media and the target does not boot, in this case we can recover U-boot in two methods. One is boot U-boot in USB debug mode and another method is boot U-boot from the microSD card. Here I'm going to show you boot U-boot from the microSD card, then update U-boot image from Ethernet. We have mentioned recovery procedure in our help documents. Open Digi website. Here type Nano. Click on ATM Nano board and documentation portal. Click on active documentation. Click on recover your device. And here we have mentioned details. Recover your device. Boot U-boot from microSD card or boot U-boot USB debug mode. Boot U-boot from the microSD card. We need microSD card minimum capacity 2 GB. Then first of all we need to create bootable microSD card. Once it boots successfully, then update bootloader from Ethernet. This is the U-boot file we have to download. Please download this image. I have already downloaded this image and copied here. Later on we need this file path. Now we are going to create bootable microSD card. Open terminal program in Linux machine. Connect microSD card to the Ubuntu machine using card reader. Then check microSD card node assigned by Linux machine using dmesg command. I'm using 16 GB microSD card. When I checked using dmesg command, it is showing SDG. This is microSD card address. We need this address to create bootable microSD card. Now write the U-boot image file to the microSD card using dd command. Sudo space dd space if is equal to U-boot image file path / U-boot file name space off is equal to /dev /sdg space bs is equal to 1k space seek is equal to 32 space oflag equal to sync. Press enter. There are no errors, so bootable microSD card is ready. We use this microSD card to boot ConnectCore ATM Nano board. Connect the micro USB cable to the USB console connector on the board and to your host computer. Open terminal emulator application. Choose correct COM port, in my case it is COM8, and choose baud rate 115200, then click on open. Insert bootable microSD card. Now insert LAN cable. This Ethernet will be useful to update U-boot image from TFTP server. Now set switches S1.2 and S1.3 to on position. When we power on the board, it should boot from microSD card. Power on the board and check terminal application. We can see boot information at terminal emulator application. So it is booting from microSD card. We can see boot SD1. So this means it is booting from microSD card. Now we are going to update U-boot from TFTP server. Now we are going to set IP address TFTP server IP on the Nano board. I have connected Nano board and my Windows PC through LAN cable. Now I am checking Ethernet settings on my PC. My system has 192.168.1.200. We need to set this IP address as server IP on the Nano device. First set IP address. Set TNV IP ADDR 192.168.1.250. Then set server IP. Set TNV server IP 192.168.1.250. 168.200. Then save env. This is saving environment variables. Now we are going to update U-boot image. Type update space U-boot space tftp space U-boot file name. Just copy this file name and paste over there. Press enter. Open TFTP server. I am using Digi TFTP server. You can use any other TFTP servers. Under Edit Preferences, we need to set U-boot file path. In my case, it is c:/tftp root. Now run TFTP server. Now U-boot is uploading. Yes, U-boot has been updated successfully onto the module's eMMC. Power off the board and set S1.2 and S1.3 to off positions. Now remove microSD card. Then power on the board and check U-boot console. It should boot from module's eMMC. Yes, it is booting. You can see that it is booting from module's eMMC. This is the recovery procedure we can follow when the device is not booting from eMMC. Thank you for watching.